Good day, everyone. Today we're going to talk about electronics 2. Electronics 2. Yes, like today I'm going to give an overview about the module. I know some of you didn't understand electronics 1. Maybe you pass, but you didn't, maybe you understand, but not really. In electronics 2, we'll use the same book like the one that we use for electronics 1. But from this time, we're going to study from we'll start from the same book, but from chapter 6 to chapter 11 of the same book, electronic device. Chapter 6, it's about amplifier. Chapter 6, we're going to talk on chapter 6. On chapter 6, we'll talk about amplifiers. We'll talk chapter 6. In chapter 6, we'll talk about amplifiers. We'll talk about amplifiers. We'll talk about amplifiers in chapter 6. But before we talk about amplifiers, there's this electronics device that we're always gonna use this semester. That we study the same device, the same component on electronics 1, which was the transistor, a BJT transistor, something like this, which was a BJT transistor. C, E, and B. Sorry, let me draw it properly. There's this device we study in electronics 1. It was a transistor, a BJT transistor. It was a BJT. That stands for bipolar, stand for bipolar junction, T for junction transistor, for bipolar junction transistor. So the BJT stand for bipolar junction transistor. So we learn about that. We learned that transistor in electronics 1, specifically in chapter 4 and chapter 5. We say that transistor has three polarities. That transistor has three terminals. Collector. We have emitter, and then we have a base here. So C for collector, and then E for emitter, C for emitter, and B for base. And B stand for base. So we have three terminals. And in this type of transistor, we say like we have two types of transistors. The same type of transistor, we have two of them. This case, this one where the arrow is pointing down like this, this one, they say this one is the NP. Sorry, let me use another pen. We say like this one is the NPN. It's a NPN type. We have two types. This is the NPN type. Why? Because the arrow is pointing down outside of the junction. And then we have the second one, which is the PNP, that look a bit like the one like we just draw, but the only difference now, the arrow is pointing in. So more about like this. Still we have the collector, we have the emitter, and then we have the base. So this one is a P N P. So we study about this electronic component. Which is the transistor. And more on chapter 6 and chapter 7, we're going to study the same transistor. But now we're going to connect it in such way, we're going to connect it as an amplifier. So we're going to connect the same component but has a amplifier. So, like I said, we can't move straight to the main purpose of this chapter without understanding how this transistor works, because we must understand for us to be able to go that side, and we must remember ourselves about the formulas and everything we covered in chapter 4 and chapter 5 of electronics 1. So I'm gonna remind you again with those formulas here. I'm gonna draw that one of the transistor. Let me draw the NPN. Is the NPN. Got it, NPN. We have the collector, we have the emitter, and then we have the base. So let's see now. But there's some two digital analog, or I'm going to show you some measurement from this transistor. If you still remember from electronics 1, we say if we measure, we take our multimeter, we measure from this side and this side. So which means we put the we take our multimeter, we measure this side and this side. We're going to measure a certain voltage that we call VCE. If, for example, they say measure VCE, we measure VCE from this side to this side. We measure VCE. We have another type of voltage that we measure from this side. Let's say from here to here. We have another voltage that we measure from here to here. Sorry, let me represent it, which is another voltage that we measure from here to here, which is called, let me write properly. Another voltage here that we call VBE. Base emitter voltage, from here to here. We have another voltage that we measure from here to here, from here, which is VCB, that we measure from here to here. And then this is if I'm representing the voltage, our variable voltage, like the voltage that we can measure using this transistor across the transistor. This is in terms of voltage. I'm going to represent the same transistor, but this time I'm going to show you how the current flow. The same transistor, the NPN, but it's the same thing, and the P and the PNP, the same procedure, same way. In this current, now we're going to represent current. The current that will flow from here to here, down here, so which means that this way. We're going to call this current IE, which is the emitter current. And then the current that will flow from here to down, going to call this current IC. We call that current IC because we are on the collector side. And the current that will flow from this side, I'm going to call this current IB. Going to call this current IB. One thing that you must know, current IE here, IE, because if you check our transistor, this current will flow down, this one also will flow here. So IE here, we can say IE, it's a sum of IB plus IC. But the fact IB will be very small, IB with the value of IB will be very small, compared to the value of, sorry, it's IC here, compared to the value of IC. So IE will be approximately equal to IC. IE will be approximately equal to IC. And then this actually how we represent the current and the voltage through our transistor. So now if you've been asking to find VCA and the BJT transistor, you know that we measure VCE from here to this corner, or VCB from here to here, and VB from here to here. And then the value of VBE is like is approximately like the value of the diode. If you know the diode, the value of the diode of the voltage of the diode, it's gonna be approximately equal to 0.7 volt. For the NPN, and then for the VBE, it's gonna be approximately to 0.7 volt for the PNP. Like I say, I won't waste too much time. It's just a overview about the transistor. So these are some of the variables that we need to understand. How does it work in our circuit, and then where can we find it? Maybe if you've been called on campus to measure certain voltage, you must know this, where we measure VCE, VE, this is where the current flow. And then on chapter 5 of our electronics 1, we study about one circuit that we call, we study bias, how to bias the transistor, different type of bias circuit, BJT bias transistor circuit. One of the one we're gonna use here in chapter 6, which means with our amplifier, is this one we call voltage divider bias circuit. Is the one we're going to deal with this semester in chapter 6. Voltage divider circuit. Voltage divider circuit. So, or voltage divider bias. Let's call it voltage divider bias. We study this type of bias in chapter 5 of electronics 1. It's kind of something look like that, something like this. We have a voltage here that we call VCC, and then we have a resistor here that we call RC, and then connected to the transistor, and then we have one resistor. Let me draw it properly. So we have VC, the voltage. We have a resistor here connected to the transistor. We have one, yes, we have two, can have this one. We have another resistor here. Here we're going to have one, let me just represent one resistor like the way you did it in electronics 1. We have one resistor, which is this one. Oh, why is so dirty? Yes, we have this is a resistor, and then we have ground. Let me represent ground like this, connected here. We have another resistor here connected to ground. So we said like the way we learn in electronics 1, we have RC, we have RE, we have R1, we have R2, and then we have VCC. This one of the bias circuit we study about electronics in electronics 1. And then in this circuit we learn how to calculate what we call voltage VB. We say VB, we measure VB from here to this side. If we measure, we take our multimeter, we measure here, we're gonna measure VB, and VE, we measure VE from here to here. Here we're gonna measure this voltage that we call VE, and then VC will be from here. Here we're gonna measure VC, and then we learn like to calculate VC. To calculate VB, VB will be R2 over R1 plus R2 times VCC. And then something else as we learn, we say when we calculate VE, VE will be equal to what? VE will equal to the current that will flow this side. So we're going to have VC is going to be IE times RE. And then VE, as the current I is the current that will flow here. And then we learn also to calculate VC. We say VC will be equal to what? VC will equal to VCC minus VRC. Here, because when we check VCC here. So we can say here VCC is equal to VRC plus VC. So that's why in this formula we make VC subject of the formula by saying VCC is equal to VCC minus VRC. This works if we have a resistor here RE. If we have a RE, if we have RE, but without RE, we're going to say without RE, we're going to say VCC is equal to VRC plus VCE. If we don't have this guy RE, this one is without, if no RE. So what else? Something else that we learn also, we say also IE. We learn also about beta DC. Sorry, we learn about R in base. These are calculation like we did for this transistor, for this circuit in electronics 1. R in base. We calculate also R in base for this circuit. R in base, I put capital letter because it's a DC circuit. We deal with DC values, which was like DC, beta DC times RE. I said for VB has two formulas. We have formula of VB which is also the same like what we did here, VB and V. Let me erase here. Let me erase everything here and explain. Like we learn about this word, like we say stiff and not stiff. Is our circuit, our transistor is stiff or not stiff? That's the part that we learn. Like we say, like we have two formulas of VB. We have this formula also VB, which is equal to R2 parallel to R in base. R parallel to an R in base over 1 plus R2 parallel to R in base, parallel to R in base, parallel to R in base. Parallel to R in base. So I said to pick between. During the test they won't tell you which one you must use or which one you must not use. This VB is if our transistor is stiff, and this one if our transistor is not stiff. Not stiff. To do that test, to do the test, like to know if your transistor is stiff or not stiff, there's two calculations we're going to cover here. You must first calculate R in base, this one, and then you're going to calculate 10 times R2, 10 times R2, 10 times R2. The answer that you're going to get here and the answer that you're going to get here, you're going to compare these two answers. You will compare these two answers. We compare these two answers. If this guy, if R in base is greater than 10 times R2, so which means R in base is greater than 10 times R2, which means the circuit is the transistor is stiff, we will use this formula, this one. So if it's the opposite, now it's like R in base is less than R2, we use the not stiff formula. So in general, this is what I can give you. I can give you, like, reminding you about what you covered in electronics 2. So on the following video, we'll carry on with just chapter 6. Sorry, I just remind you a few things, like maybe you forget about electronics 1. That you're gonna need in electronics 2. Thank you for watching the video. Just keep checking the group. I'll always update you in new videos and everything. Thank you and bye.